What I would like to show you today is how to use the standard normal table. You'll find this in your yellow packet that you have, so I'd like you to have that out and be following along and looking some things up. This is something that you will have access to on any test that you take in here, as well as the AP statistics test. And again, this is how to find probabilities and also or percentages on from the normal model. Remember, on a normal model, we have got 0 is the mean, and so you're going to find that right at the center. And if we mark off 3 standard deviations, we should just about cover, in each direction, we should cover the entire area underneath the curve. So this would be, on the standard normal, this would be a standard deviation of 1, 2, and 3. Going the other direction, the same thing would be -1, -2, and -3. So again, how to calculate the z-score is you're going to take your data value, x minus x bar, divided by the standard deviation. This is if you're talking samples. If you're talking the population, you're going to have x minus mu over sigma. So generally, when we're dealing with samples of data, we'll be thinking of it in terms of this for this first part of the course. So what I'd like you to notice on this table is you actually have 2 pages of this, and it's actually quite long. So this is the one, and notice that the z-score values only show the negatives. So see here we have, this would be a z-score of -3.4, and then you'll see that the hundredths place is across here. So -3.40 all the way to -3.49, and then you'll see -3.30 continuing on. Now on the other page, you'll see all of these other values. So we have the positive values on this side. The other thing that I would like you to notice about these pictures that they show you, notice that the shading is to the left, and that's going to be important, and I'll show you when I do some examples. And here the shading also is to the left. So the first example I want to take a look at is on page 126 in your textbook, number 29. And the directions, or the question is, what percent of a standard normal model is found in each region? Draw a picture first. So drawing a picture is crucial, so we are going to be doing that. So when I draw my normal model, first I have a z-score greater than 1.5. So I want to know, how unusual is that to have that kind of a z-score? So I'm going to label my 0 in the middle, and since I'm only going to the positive direction, I'm going to label 3 going this direction. So if this is 1, this is 2, then we're looking at 1.5 being about here, and I want greater than, so I'm going to shade this region here. So I'm trying to find, remember the whole area under the curve is 1, and I want to find the proportion that's shaded green. So clearly this is less than a half. We can tell that for sure. We can see that from the picture. So I'm going to go to my standard normal table. I don't want this one because these are all z-scores of negative. So I need to find the one where it's positive. I'm looking for 1.5. So I can find the 1.5, and it would be 1.50. So it's actually this value right here. Now remember, we just looked at our picture and we said it was less than 0.5, less than half. But this value tells me 0.9332. Now the reason that is, remember, this value is the shaded area to the left. If my picture is to the right, then that means I'm going to have to subtract from 1. Remember, 1 was the area of the whole thing. So I'm going to go back to my picture. This right here is 0.9332. I need 1 minus that. So I get 0.0668. Now, it does say what percent, so I could say about, I'll just say 6.68%, moving that 2 places. All right, next problem asks for a z-score less than 2.25. So again, I'm going to be I need the positive one, so I'm going to find 2.25. So here's 2.2. I need to come over here to find the 0.05 part. So I'm looking where the column and row intersect. And it looks like I have a value of 0.9878. So let's go back to our problem, 0.9878. Forgot my picture. Better write this down. So let me go ahead and draw this picture. Not much of a line there. And here's 0. Again, I'm doing positive numbers, so I'm going to go to the right. 2.25, about right here. And this time I want shaded to the left. So I'm actually looking at this whole region. Clearly it's more than half. And take a look here, here's my answer, and that's actually it. So this time it was less than. So when it's less than, you don't have to subtract. So we have about 98.78% is shaded to the left of that value. The next problem, a little interesting, because now I have two values. I'm saying that z is in between -1 and 1.15. So I'm going to start with a picture. I think they're getting worse each time. So this time I have some positive, some negative. So I'm going to go ahead and mark off 3. Well, I'll just record those 2. And now I'm looking for in between -1. So I'm going to mark the -1 here and 1.15. So I'll kind of pick where I think that is. So now I'm looking for this region. So we have to think about how are we going to find this region. So we're going to pause this for a moment, and I'm going to have you guys think about it and talk about what we could do to look up these scores so I can come up with the shaded region in between. All right, so hopefully we've talked about it. And I'm going to look up the 1.15. So when I do that, I get 0.8749. And then I'm going to look up -1. So this time I'm on the negative chart. So I need to scroll down here a little bit more. So -1 is 0.1587. And then we're going to subtract that to come up with our answer. And we get, let's see, 0.7162. Okay, for our next one, again, we're going to start with a picture. And I'm going to label this. With 3 standard deviations each direction. And now I have to think about what this means. The absolute value of z is greater than 0.5. So remember, absolute value is our distance from 0. So my distance from 0 needs to be greater than 0.5. I need to be more than 0.5 away from 0. So now what I don't know is, am I to the right or to the left? I don't know which direction I am. So here's 0, and I need to be more than 0.5 away. So here's 0.5. And if I need to be more than 0.5 away, then I need to be in here somewhere. But I also could be more than 0.5 away if I'm in the negative direction. So here's -0.5, and I need to be more than 0.5 away. Now if you remember from Algebra 2, when we solved absolute value inequalities, we broke it into 2 cases. Z is greater than 0.5, or, and remember, greater, Z is less than -0.5. And that was how we solved absolute value inequalities, and that's exactly how I kind of just reasoned through on this one. So now we have to come up with a way that we can figure out this region. So go ahead, and we're going to pause this again, and you guys can figure out how you're going to do this. All right, So hopefully he came up with a plan. And so on this one, we've got symmetry going on. So if we know this region here, if we know this side, all we have to do is double it. So we're going to look up negative 0.5 because then we don't have to subtract it from 1. So that's going to be this chart. I look up negative 0.5, so that means I have to find the right here, negative 0.5, and I get this value, 0.3085. So we're going to take 0.3085, but then we have to double that. So we get 0.61, 70. So now we're going to change it up a little bit. So this is number 31 from your textbook. In a standard normal model, what values of z cuts off the region described? And don't forget, we always need a picture. So first I want to know the highest 20%. So I'm going to start with a picture. And I'm going to draw what I think maybe represents 20%. So, and it's not that you have to be perfectly accurate in that. You just want to make sure you're in the right half. So the highest 20%, I'm looking for something up here. So what I'm looking for is, now the question is, what's the z-score that corresponds to this? Now, we're going to use our table, and we're going to work backwards. But you do have to remember that if this is 20% or 0.2, then that means that this is 80% or 0.8. Remember that our table shows to the left. So I'm going to need to find out the z-score that corresponds to an area of 0.8 to the left. So I'm going to look here. Remember, I'm looking for 0.8 to the left, so I have to look in the body of the table. Well, clearly I'm on the wrong half in my picture. So I'm going to have to go to this part, and I'm looking in the body of the table, and I want to find the closest I can find to 0.8. So as you kind of scroll through, here I can see I have 0.7995, and here is 0.8023. So this one is actually a little bit closer, not much, but just a little bit. So I'm actually going to use this value. And you don't have to do anything fancy and go in between them, unless maybe it was halfway exactly in between. But this is pretty close to 0.8. So now I have to find the z-score. So I look over here and I see 0.8. And then I look up here for my hundredths place. So it looks like I have a z-score of 0.84. And that's actually my answer. So z equals 0.84. And that z-score, so remember what that means. Z tells me how many standard deviations above or below the mean I'm at. So I'm not quite a standard deviation above the mean. Now I want the lowest 3%. So I'm going to, again, start with my standard normal model. So 0, I'm going to mark off 3 standard deviations each way. Didn't do a very good job on that one. But I want the lowest 3%. So we're looking way down here. So this area, 3%, would be 0.03. Notice I am shaded to the left. So I'm actually going to look up 0.03. So I'm going to come up here. I need to be on this one where I'm shaded, my shading's to the left, clearly less than half. I'm looking for 0.03 in the body of the table. So I hunt through until I find that. And I want to get as close as possible to 0.03. And I think this is as close as possible. 0.0301. And if I look at that value, I see it's negative 1.88. So we get z equals negative 1.88. So we're talking almost 2 standard deviations below the mean, which is unusual to be that far below the mean. There's only a 3% chance that you would be that low, or we would have a value that low. Okay, the last one I want is the middle 90%. So we're going to have to do some fancy stuff. You probably could guess subtraction like we did before. So we have 0, 1, 2, 3. Again, not the greatest there. And the middle 90%. So that means I'm going to have some value here, some value here. I want 0.9 to be in the center. So I want this to be 0.9. Well, think about how much that leaves. That leaves 10% left, and that has to get split on the two sides. So when I look this up, now remember, this z-score, we got symmetry going in our favor. And this z-score, they're just going to be opposites. So if I look up one of them, so I can look up 0.05 in the body of the table to find this z-score, and it's going to be negative, then I know this one is just going to be the opposite of that. So let's do that. Let's look up negative 0.05, or I'm sorry, just 0.05. So if I look up 0.05, the closest I can come to that, actually this one's split right in between. So because of that, I'm going to go ahead and split that difference, negative 1.645. If I split in between, negative 1.645. So if we go back here, we would have negative 1.645, which makes this a positive 1.645. So these would be the two cutoff scores to give me the middle 90%. So what do you do if it's not a standard normal model? For example, the Angus steer problem that I think we looked at once before, the weights follow a normal model with a mean of 1,152 pounds and a standard deviation of 84 pounds. What percent of steers weigh over 1,250 pounds? So what do you do if it doesn't follow a standard normal model and you don't have a table for a normal model with this mean and this standard deviation? Well, you standardize it. So you're going to take and find the z-score. So remember, it was x minus x bar over the standard deviation. So you're going to take 1,250 minus the mean, 1,152, and divide by the standard deviation. So that gives me, round to two decimal places, and I get 1.17. So now I'm going to draw my picture. Don't forget to draw a picture, because that's really going to help you make sure you remember if you're supposed to subtract from 1 or not. So I'm looking for 1.17, so it's about here. I want over. So I'm going to be looking up the value of 1.17, and since it's above, I'm going to have to subtract from 1 to figure out this. So I'm going to look up 1.17, 1.17, 0.8790, and that's this, 0.8, oh, that's not that part though, 0.8790, so we have 1 minus 0.8790, so we get 0.120, well, hold on just a second. Okay, bad memory. I couldn't even remember if I wrote the right number down there. So we have, okay, but it was 0.8790, so we get 0.1210, and that would be the area that is to the right. Okay, so if we wanted a percent, what percent? We would have 12.1% of the steers weigh over 1,250 pounds. For the next one, under 1,200 pounds, find a z-score. So we're going to take z equals, x is 1,200, our mean is 1,152, and our standard deviation is 84. So we can make that calculation, and we should get 0.57 because we just go two places. So this time, when I do my picture, I'm in the positive direction, and And so 0.57, maybe about right here, and I want under. So no subtraction on this one. I am looking at 0.57, and that means I need to be on this side. So 0.57 is 0.7157. So we have, now don't get this confused with the z-score, because this is the area that's to the left of that z-score. So we get about 71.57% of the Angus steers are lower or underneath 1,200 pounds. And for the last one, we're going to take, we have to find two z-scores. So you're going to have to do the left side, you would have 1,000 minus 1,152 over 84. And then you'd have to find your other z-score, 1,100 minus 1,152. And once you find that, you'll draw your picture, you'll find in between the two. So that would involve some subtraction. But we've done the other z-scores. I think you get the idea now, because once you convert it to a z-score, it's just like the other problems. And that is the way that you would do those.